Hello, so the first video for tonight is going to be following on from curve sketching, and as you can see I've already picked a curve there. So going y equals x squared on x squared minus 4, plus 3. So again, remember you've got your Dr. Isaac if you want it, and you also got the way I do it, which is asymptotes, intercepts, limits, calculus. But even now you might see me do something different. Now it's kind of, I want you to think of it as a very fluid process, and you kind of just do whatever you need to do at any given point in time. So firstly I'm going to do with the domain. So if you look at it, hopefully you can see that all that really matters is that this can't be 0. So x squared minus 4 can't be 0, which means that x can't be either plus or minus 2. So that gives me my two asymptotes at minus 2 and at 2. Okay. Next of all, I want to think about intercepts. You might like to think about range, because the range, if I go back, probably looks like it might be pretty reasonable. Like obviously that plus 3's got something to do with it. But let's look at intercepts. I'd rather do that. So I get that x squared, switching to finger, on x squared minus 4, let's just check, that's right, plus 3 equals 0. So then if I subtract the 3 across and I multiply out the x squared minus 4, I get that, and then I'll expand this and add the 3x squared across, so I get 4x squared equals 12, not 4. So x squared equals 3, so x equals plus or minus root 3. Now root 3 is about 1.73, I think, from memory. So my roots are there and there. Okay. So I'm gradually developing my information. I'm going to rub this out now, so if you need to, pause for a second. Alright, so the next thing I want to do is I want to think about my limits. So I want to think about what happens when x approaches 2 from below, when x approaches 2 from above. So technically what I'm doing is I'm doing the limit as x approaches 2 from below of x squared on x squared minus 4 plus 3. Which basically means, in the grand scheme of things, I'm substituting some number in, minus 2, not 2, minus 2. Substituting some number in that's slightly smaller than 2, so I'm going to pick minus 2.1. So if I look at minus 2.1, so the top is positive, and the bottom is negative, and it's a very small number. Oh no, sorry, it's also positive. Sorry, my bad. So they're both positive, and the bottom is very small. So I get a very big number, and then I add 3 to it, which is still going to be a nice big number. So that tells me that my curve looks something like this up here. And then for minus 1.9, so the limit as it approaches minus 2 from above, I get that the bottom is now 1.9 squared minus 4, which is negative. So it looks something like this. Now at this point I'm going to pause for a second, and I'm going to go back to Dr. Isaac, and I'm going to think about the S, I'm going to think about symmetry. Hopefully you can see that this is even. Okay. Which means that I can basically draw my whole function now. I'm going to guess what it's going to look like roughly, and then we're going to fix it up as we go. I reckon it's going to do something like this. Something like this, and I reckon maybe this line might be 3 or something. And then it's going to be a parabolic shape in the middle there. Okay. I know that the limits part is accurate because those things that I'm circling now have to be symmetric. I don't know the other stuff is accurate, but I can prove it using calculus. Okay. So I'm going to go on to a new slide. And I'm just going to pause while I write some stuff in. Alright, so I've added some of the information on the graph. And I've also taken the first derivative over there as best I could. So I set it equal to 0, which gives me, if I expand all that out, I get 2x cubed minus 8x minus 2x cubed equals 0. So I get x equals 0 is my only stationary point, and I can see by looking at the limits here and here that it must be a maximum, right? Because I have to go up through the root there, and I have to come back down through the one on the other side. And it's just a matter of seeing what value it takes. So y equals 0 plus 3 at that point. So there's my value of 3. The only other thing I need to know now is what happens as x approaches infinity. Yeah, so I'm going to do some strategic erasing again. And I'm going to do exactly the same thing we were doing today. So the limit as x approaches positive infinity, and remember it's an even function, so anything I do over here will work for minus infinity as well. So I'm just gonna write L for limit. Oh, maybe I write limit, but I just won't write the thing at the bottom. So just in the fraction only, I'm going to ignore the 3. I can just add the 3 on at the end. I'm just going to divide the top and bottom by x squared. Okay. And now this, when I take the limit, is 0. So that means that my limit is 1 plus 3, which is 4. So in fact, the asymptote that I thought might be at 3 happens to be at 4. And my curve looks like this. Okay. Shouldn't curve down there, sorry. Okay, but something like that. That's nice. Alright, so hopefully that's answered some of your questions. Please do some more practice of this tonight. And I'll let you do some in class tomorrow. So hopefully we can polish this out before the end of the term. Alright, thanks guys. Don't forget, one more video on integration by first principles.